Hi guys, and welcome to another video, and this is part 2 of grade 11 maths quadratic number patterns past exam question from the November 2019 paper 1. If you remember or looked at the previous video, you'll be able to see that we have covered everything up until 4.1.4. Okay, so if you haven't watched that video, watch part 1 first before looking at part 2. It says here in this particular question, show that all the numbers of this quadratic number pattern will be odd numbers. Okay, and it's for 2 marks. So we need to look at the general term of the quadratic sequence that we just found. And the general term is here, right? So there's the general term here, which is Tn equals to 2n squared plus 8n plus 3. Now, we need to show that all terms are going to be odd. So let's have a look at that. So the question number is 4.1.5. Okay, so we're looking at this question here. Let's write that down. So in 4.1.5, we'll write down our formula. Tn equals to 2n squared plus 8n plus 3. That will be plus 8n plus 3. So in this particular question, it's for 2 marks. So in some questions that are more complex, we would be required to write in the completed square form and so on. But I think this is a more basic question. How can we show that this is always going to be odd? Well, one thing that we can do is use our knowledge of even and odd numbers. For example, if you look at here, you've got 2 and 8. If I take out the 2 as a common factor, I'm left with n squared plus 4n, and I'm left with plus 3. So let's see what happens from here. Got 2 times n squared plus 4n. So I got 2 times, it doesn't matter what value I put in here for n. 2 times any number will be even. And I do have an odd number here, which is 3. So basically an even number plus an odd number will always return an odd number. So basically that's our solution to this question. Let's look at 4.1.6. So there's no 4.1.6, it's 4.2. Alright, 4.2. Okay, there you go. It tells us here that 4x and y and minus 11 are the first 4 terms of a quadratic number pattern. Then they tell us that 2p minus 4, p minus 3, and p over 2 minus 1 are the first 3 terms of the first difference of the same quadratic number pattern. Calculate the values of p, x, and y. So basically what we have to do is use the following. Firstly, in a quadratic number pattern, the first difference is a linear number pattern. That's one thing. The second thing is that the second difference is constant in a quadratic number pattern. The first 3 first differences of the same quadratic number pattern. So we already established and know that the first difference of a quadratic number pattern is a linear number pattern. Alright, so let's see how can we now solve this particular question. So we got 2p minus 4, p minus 3, and p over 2 minus 1. So what do we know about the second difference of a quadratic number pattern? I just mentioned it, it's constant, which means it's the same. So let's write down 4.2. We're going to use that property. So for 4.2, we're going to have the following, right? So it's going to be T2. For this here, p minus 3 minus 2p minus 4. So I'm going to be subtracting here. P minus 3 minus 2p minus 4. So let's write that down. P minus 3. So I'm saying p minus 3 minus. So I'm saying basically like T2 minus T1, right? Minus into 2p minus 4 minus into 2p minus 4 will equals 2. I'll explain why I'm writing equals 2. And this is now going to be essentially T3 minus T2. So P over 2 minus 1 p over 2 minus 1. Let's write that down. P over 2 minus 1. And we're going to subtract the second term there, which is p minus 3. So minus into p minus 3. P minus 3. Right, so let's solve now. Now, the reason I equated it is because the second difference of quadratic number pattern is constant. Constant means the same, so now we can equate the second differences. So therefore, you're going to be left with p minus 3 minus 2p, if I open the brackets, plus 4. And here I've got p over 2 minus 1 minus p plus 3. Now let's simplify and see what we get. So p minus 2p will be minus p minus 3 plus 4 is plus 1. And here I got p over 2 is half p minus p. So half p minus p is minus half p. So it will be minus half p. And here I got minus 1 plus 3 is plus 2. So let's see what we can get from here. So as you can see now, I'm going to take this minus half p to the left hand side, and I'm going to be left with the following, which is minus p plus half p. If I take this 1 over to the right hand side, it's going to be 2 minus 1, which is equal to 1. So minus p plus half p is minus half p equals to 1. Therefore, p equals to, do you know the answer? What's 1 divided by half? You can either say that, or you can multiply across by negative 2. And if you now do that, 1 divided by minus half will give you minus 2. Right? Now, in a worst case scenario, if you wanted to, you can just quickly use your calculator there, right? For example, 1 divided by minus 1 over 2 equals to, right, minus 2. So that's our solution. So therefore we got p equals to minus 2. Now we need to find x and y. Right, so let's go back to the question. So what do they tell us here? Right, so now we know that we got 4xy minus 11, and these are the first three differences. Right, so we got 4xy and minus 11. Let's write that down. 4xy and minus 11. So now we've got 4x, y, and minus 11. Now don't forget that this is my sequence Tn, so that's n, so that's first term, second term, third term, and fourth term. Then now my first difference will be, the first term of the first difference is, there's a check, 2p minus 4, so that'll be, we just solve for p, which is negative 2, so let's see, 2 times minus 2, that will be 2, so I'm just substituting minus 2 now, because we already solved for p, and that will be minus 4, so 2 times minus 2 minus 4 equals 2 minus 8. So now I've got minus 8 is the first term of my first difference, so that will be minus 8, so that will be minus 8 there, and then here, so as you can see, we now got 2 times minus 2 minus 4. So if we have to now look at it, we got 4 minus 8. 4 minus 8 will equals to minus 4. So the value of x is 4 minus 8, which is minus 4. So what we are now looking at is basically getting the second term of the first difference. The second term of the first difference is p minus 3, which is minus 2 minus 3, which is minus 5. So the second term of the first difference is minus 5. So as you can see, we've now got the first term of the first difference is minus 8, and the second term of the first difference is minus 5. So our answer for x will be 4 minus 8, which is minus 4, and our answer for y will be minus 4 and minus 5, which is minus 9. That's our solution for y. Y equals to minus 9 minus 9. Okay, let's do the working. We'll say minus 4 and we're adding it to minus 5, and that gives us minus 9. That is, if you haven't subscribed already, subscribe to J Maths. You can like my Facebook page, Justin Lazarus Mathematics. You can watch all videos in order of the work schedule on jrmaths.com. And I'll catch you in the next video.